Hello guys, it's been a while since I posted. I recorded these videos a couple months back, but never got the chance to upload them. So in this new series, we'll be designing and coding up a project, and we'll learn backend programming or server-side programming, how to design a software project, and some of the tools that goes with developing a software project. So let's begin. So these are the topics we will cover in this video before we introduce our project. We have to go through multiple phases when we're developing a software application. This term is called software development lifecycle. We first have to do an analysis of software requirements that is given to us, or we have to define the software requirements before developing any software product. This document is also called SRS, Software Requirement Specification. Then we start the design phase. This may include UML class diagrams, function calls, or the architecture of the application. Sometimes this phase may also include POCs, proof of concept, to test out some of the tech before finalizing the design. After the design has been finalized, we can begin the coding phase, where a team of engineers work on developing the software. After coding has been completed, testing phase begins, and this is where we may go back and forth between the testing and the coding phase. This will also include a variety of tests, such as functional tests, to ensure all the features are working as expected. It may also include load tests to test if the system can handle and perform well when under load. After testing, when everything has been checked out from security to load testing to functional tests, we can begin the deployment to production environment. And the last phase is maintaining the application, keeping it up to date with the libraries and other tech. This stage should be considered very important, as the application should be easily extensible and be able to incorporate new features easily. Lots of companies don't maintain their product well, and it becomes very difficult to update it down the line. Latest example is Siri. It was found out that the Siri codebase was very clunky, and it was difficult to add even basic features to it. So this stage should be considered very important when application has been developed. Agile Methodology's main goal is to focus on user input experience. It's a project management framework. We have to follow specific steps when developing a product, and ensures that the project is being developed timely and feedback of customers or clients is being taken into consideration. A product is designed by a team. It doesn't just consist of software engineers, but also project managers whose job is to ensure a project is progressing in a timely manner, and any business-related questions are being properly translated to software engineers. Scrum Master's job is to ensure the Agile methodology is being followed. Team works in sprints, which can range from 1 to 3 weeks usually. Scrum Master's job is to also hold daily stand-up and to get an update on the work that's being done, to hold refinement meetings so the next sprint tickets can be planned out, and also hold retrospectives to reflect on how the sprint went and if there's any processes that can be improved. Agile is a flexible methodology in a sense that you can go back and improve. This ensures that the product that is being developed takes customer feedback into account and improves the overall product's quality. What is Git? Git is the most popular distributed version control system. It is a fundamental tool for software engineers. Version control helps track all the changes made to the code in what's called a repository. We can easily see what changes were made, who made them, and when they were made. If there is a bug or issue introduced, we can easily revert the code, as it stores multiple versions of the code in a repo. Without it, we could have tons of copies, and there would be no way to manage the code base properly, especially if we have multiple people working on the same code base. We can manage our code and store them in a repo. There's always a backup in a Git server if our computer were to ever crash. Git gives us an easy way to collaborate. In a team of developers who are working on the same code base, a developer can easily collaborate by raising what's called a pull request and getting their code reviewed, adding comments, and so on. We will learn how to use Git later in the video. Integrated Development Environment, or IDEs, are an environment for developers who write or develop code. Back in the day, people used to write code on Notepad and manually compile or build code via terminal. IDEs have made programming a lot easier and faster, as they provide a lot of tools for building applications quickly, ability to debug. They have IntelliSense, which helps give suggestions and even helps autocomplete code. They have built-in compilers to easily compile and even package our code. There are lots of IDEs available now for developing code in any languages. We are going to be using IntelliJ for the project we are going to do, as it's a very popular IDE, especially for Java development. I want to briefly touch on the topic of databases and caches, as we'll be using it in our project. We might use a cache if given time, but we will definitely be using a database. Database is pretty much a way of storing the data in an organized manner and can be used by many users simultaneously. There are many variations of databases now, from Oracle, MySQL, SQL Server, and Postgres. The language for database is called SQL. The databases described above are all relational databases. In the past decade, non-relational databases have become very popular. They often are faster than relational database as there's no relationship between the tables. Non-relational databases have their own storage models, and some of the examples are MongoDB, which uses document store, Cassandra, which uses a key value store. At the end, it all comes down to what type of data we're storing, and how much data we're storing, what the relationship between the data is when deciding which type of database to go for. There's a lot that goes into when designing a database, as structuring or organizing the data is very important if you want optimal performance. If you want to retrieve data in the fastest way possible, we need to use a cache. Caches like Redis are best for storing data, and these caches use RAM as a primary storage. Getting data from the database will always be slow when compared to a cache. If you buy a CPU, you'll see that CPU nowadays have L1, L2, and L3 caches. And these CPUs are running at 4 GHz or higher, and the system memory RAM is not fast enough for these CPUs. So these 3 levels of caches were introduced that store small chunks of frequently accessed data, or the addresses of the data nearby. Caches can be a pretty complex topic, and there are a variety of ways we can implement it in our application, all depending on our use case. These are some of the examples of caching technologies that we can use in our application, Redis being the most popular among them. If given time, we'll be using Redis cache in our project, which I will discuss later in the video. We are going to be building a REST service or REST APIs for our project. So REST is an architecture style for providing a standard way of communication over web. It allows separation of client and server. Client is usually the front end like an app or a website, where when a user clicks on a button or navigates a web page, it makes a REST call to the backend, where all the logic lies, and it returns the data back to the client. This is also called server-side programming. What the separation means is that the client can be changed or updated anytime without affecting the server-side operations, and vice versa. This separation allows the application to grow and evolve very quickly. The 4 major operations of REST is known as CRUD operations, which is creating a data, and for that we generally use a POST request. For reading the data, we use HTTP GET request. For updating the data, we use HTTP PUT request, and for deleting the data, we use HTTP delete request. The preferred or the widely used format for REST is JSON. There's a little more that goes into REST service, such as REST being stateless by default. And this is a little complex topic for this video, but for our project we'll get a good intro into how to use REST service and how to build it. Docker is very similar to a virtual machine, where you can run any operating system. It pretty much packages our application into what's called a container. We can create a Linux image that has pre-installed packages for, let's say, Java, Python, or Node. It builds and packages our application into these containers. With Docker, we can very quickly build, test, and ship our application. If you want to run our application in cloud, such as AWS, we can easily deploy these Docker containers on Amazon ECS and can scale it very easily as well. Later in the video, we'll see how to set up Docker and run our application in it. So we'll be building an employee payroll system, and we'll be mainly focusing on server-side programming, so we're going to be creating REST APIs. Before diving into coding, we have to come up with an architectural design. There are many factors we should take into consideration when designing an application, such as who the user will be or the client, how many reads or writes we'll be doing, what kind of data are we storing, how frequently will that data be accessed, or how frequently will it be written. These are some of the factors we need to consider or ask when designing an application. For this project, this is the overall design that would be ideal. We will have 2 major roles, an admin and a regular client. Admin can read and write the data, and the employee client can only read the data. Our service should be easily scalable if we're running on a cloud, and the load balancer can balance that load among the different services we're running. Each of our services are running in a server or multiple servers. There's a gateway right behind the load balancer where the clients go to, and from there the load balancer sends a request to one of the employee service that is running. There are different load balancer algorithms such as round robin, which basically sends requests in a turn-by-turn way to each server. For example, the first request will go to the server 1, the next request will go to server 2, and so on, and this will repeat in a round-robin way. Other algos can even check how much load is on the server, and it will automatically direct the calls to the server with low load. The next part is a Redis cache. This is optional if you want to have a very fast retrieval of data. Caches will always be faster than a database call, as caches use memory as a primary storage. There are a couple of ways we can implement this part. One way is we can see if the data is in cache, and if it's not, it will be a cache miss, and we'll fetch the data from the SQL database and store that in Redis. So here, cache will store only the most frequently accessed data. The second way is we'll fetch data only from the Redis cache. We can prime our cache during certain times from the SQL database. What this means is we'll take the data that is stored in the SQL database and sort that data into the Redis cache. Again, this depends on our use case. Both ways can actually work for us in this scenario. Another design is very similar to the last one, except here we're using Docker as a container for our application, and using Docker Swarm to manage and direct the traffic between different Docker nodes. As discussed, we can easily package the application in a Docker container, and we can deploy this on a server or a cloud, and Docker Swarm can manage these Docker nodes, where we have our different payroll services running. For our project, this will be our architecture, just on a smaller scale. It's very similar to the previous architecture we have seen. We can easily horizontally scale this up by adding more nodes. If given time, we'll see how to incorporate Redis cache into our application. So what are we going to learn doing this? We will learn the software development lifecycle. We will learn how to design our software product and what are some of the factors we should consider when designing a product. We will learn the importance of Git and how to use it. We will learn how to set up our development environment. We will get an intro into databases and caching, and also how to containerize our application. We will also learn how to write REST APIs or learn server-side programming. And we are going to be using Java and Spring Boot framework in developing our REST APIs.